Hello, everybody. My name is Hello. Welcome back to the series where we're dealing with operating systems. This is going to be one of the final lectures of this series. We are down to the very last topic, which is called page replacement algorithms. There are three total algorithms, so this will be over the span of 3 videos. But after this, I think the operating systems lectures that we're doing will be over. So let's go ahead and see what page replacement is and how to code this in Python. Page replacement is actually a memory management technique. Okay, what that means is, let's say we talked about this already, where we say that your process is broken down into pages, correct? And these pages are something that's put inside memory. Okay, so think about it like this. Let's say you have a frame, a memory frame, okay, and it has a frame size, something like this. The frame size is 3 in this case. Okay, so the concept of virtual memory says that, right, in case my logical size, which is the size of the process, is greater than whatever is available in the RAM, what I do is I actually segment this into pages. Whatever pages is active, I will feed that to the RAM. The rest will just sit in a buffer somewhere. Okay, so that means, let's say this is what my program looks like, right? For example, let's say there are totally 5 pages. 0th page, first page, second page is called, and then 5th page, first page, second page is called again. This is what the flow is. Okay, now this is my frame. Okay, now what I will do in the memory is, whenever it's called and I have empty stuff in my frame, I will go ahead and put it over here. For example, let's say 0, 1, 2, I put these 3. Okay, now when 5 comes, 5 is something that's not there in the frame. What happens is something called as a page fault. 5th page is not there in my frame, so I have to remove one of these pages that you see here. It's either 0, 1, 2, and replace that page with page number 5. Okay, so what page am I going to replace and how am I going to replace that is where the concept of page replacement comes in. So the total 3 algorithms that we'll be looking into while doing page replacement. First will be nothing but FIFO, also known as first in, first out. Second will be least recently used page replacement, and third will be optimal page replacement. Okay, for this video, we're going to be talking about the FIFO. And in further videos, we'll talk about both LRU and optimal page replacement. Okay. So first in, first out page replacement. Let's say these are the pages that we want to browse through, and this is what we want to put inside the memory. Okay, this is the page order. Okay. Now, what does first in, first out page replacement say? When you're replacing pages and there are page faults, replace the first one which came in. That should be the first one going out. Okay, so let's go ahead and set a frame size now. So let's set the frame size to be 3. So initially, all of these are empty at time is equal to 0. Then when I move on to the first page, what happens? This will get filled up. The remaining frames will be empty. And then when I go here, again, there's an available frame. So I'll just fill that up. Okay, I'll go here, 0, 3, 1. And then I'll go over here. In this case, I have to do a page replacement. Okay, in that case, which do I replace? Well, 0 came first, so that I'll replace 0 with 2. So I will put 2 here, 2, 3, 1. Next, I'll do 4. Again, a page fault occurs. Where do I replace 4? Well, 3 came. 3 is the oldest one here, so I will replace 3. Then I'll go back to 1. 1 is already existing, so I'll just keep this as is. Then again, 2 is something that's existing, so I'll keep this as is. But now when I go to 3, a page fault occurs. Now, which one do I need to replace? Now, think about this. So in this case, what was the first thing that came in? Well, that was actually what? 1 is what we didn't replace, right? We replaced 0 and 3. So in this case, 1 will be going. So we'll go back to 2, 4, and then 3. Okay, now again, when you go to 0, 2 will be the least 2 will be the first one now, so that will go 0, 4, 3, and then finally when you move back here, you will get the same 0, 4, 3. Okay, so this is how first in, first out page replacement works. Let's go ahead and count the number of page faults here. So this is a page fault because 0 is not available. This also page fault. This also page fault. This also page fault. No page for. Oh, this also page fault. No page fault here. No page fault here. Page fault. Page fault. And again, no page fault here. So total number will be 1, 2, 3, 4, 5, 6, 7, 8. Sorry, 6, 7. This is not that. So 7 total page faults are there. So how do you go ahead and code this in Python? That's what we're going to be looking into. Let's go ahead and see what that looks like. Now that you have a grasp over what FIFO looks like in theory, let's go ahead and see what that also looks like in Python so that you know how to code this. Okay, so you're going to be doing all of this with a function, and we call this FIFO. Okay, and this will take a process list. This is all the process that needs to be loaded into along with a frame size. Okay, so this is what it's going to be like. So if it is pass over here, let me go ahead and define what the input will look like, right? So process list will be the something similar to what we just did. So it'll be 0 3 1 2 4 1 2 3. Okay, maybe I can just do it. So 0 3 1 2 4 1 2 3 and then 0 and 4. So this is going to be the processes list. Frame size is going to be 3. Okay, so let's go ahead and see what this will look like. So firstly, we have to initialize our stuff, right? So we have to, first of all, you see all of this right here, right? This below where we're actually writing this down. We have to print and at least tell that this is what it looks like in every scenario. So we have to create some sort of tracking over there, right? So let's go ahead and create a list called tracker. Okay, and let us set that list initially to empty in all these cases. So the length of the process, how much ever process is there. So the idea is very simple. I'm going to set everything to be empty. I will put this 0 here, then I'll copy this part into the next, and I'll see if anything has to change. If it has to change, it'll become a page fault. So I will copy the same thing over here, check whether if I have to change something. So that's the exact same way of how we are writing. We're just going to do that into code. Okay, so let's go ahead and first initialize all of that. Let's just set all of this to empty first of all. So that'll be just a nil for something in range of this frame size. So in this case, it'll be 3. And I can do this for I in range of len of processes. Okay, so this is going to be a nested list, and every element of this list is going to be something like that. That'll be initially empty. Okay, if you're able to understand this, then awesome. Let's go ahead and create a pointer to check where to replace. Now in FIFO page replacement, something that you can notice is, let's see this. Okay, so first time when I'm replacing, apart from filling out empty ones, you can see I'm replacing the first element. The next time I'm replacing the second element. The next time I'm replacing the third element, and then again I'm replacing the first element, right? So it goes 1 2 3 1 2 3 1 2 3. Okay, so it keeps repeating like a cycle. So let's go ahead and set a pointer called replace. Let's set that to be 0. Let's go ahead and count the page faults also. Let's set that to be 0 also. So let's go ahead and iterate through our processes. So I in range len of processes. I will go ahead and take the current process to be processes of I. Okay, now to something to check right now, right? First of all, something that we discussed is copy the previous alignment. Correct? So we're saying, if I go to the first element, go ahead and copy whatever is there in the 0th element. From there, we'll check whether there's a page fault or not. So copying will only be there if it is more than the 0th element, so that I have something previously to just copy, or else we'll start from scratch. Okay, so in that case, what I'll do is, if the value of I is greater than equal to 1, okay, from the first index onwards, do this, go ahead and set tracker of I. The ith element of this list will be nothing but the I minus 1th element. So to avoid shallow copying, let's just go ahead and do I minus 1 list of tracker of I minus 1. Okay, that will look like. So initially it'll be empty. So let's go ahead and see what happens if your process is not there in the list. So that will be common towards everything. That's what we call as a page fault, right? So how does the logic behind a page fault work? We just check if the process is not in the tracker of I. That is the ith time frame of the tracker. If the process is not there, well, that's a page fault. Correct? So in FIFO, we replace with the replacement pointer. Correct? So initially it's set to be 0. So the 0th index of the tracker will be replaced. Then what we'll do, we'll set the pointer to 1. We'll keep looping that within the frame size. So how does that work? First of all, let's go ahead and count this as a page fault. So page fault will be plus equal to 1. Let's go ahead and see tracker of I of replace. Okay, so the current element of this tracker, ith index, is going to be replaced by this process. Okay, and since this is FIFO, let's go ahead and increase our pointer. This pointer will be circular only, circular pointer. Correct? That's also something that we discussed. So replace will be nothing but replace plus 1, and then wrap this up. I'll just do some parentheses over here. Percentage frame size. Okay, so if the frame size is 3, it'll go 0 1 2 0 1 2 0 1 2 0 1 2. That's how FIFO works. Okay, so once you do this, well, that's it. So let's go ahead and just print FIFO page replacement. Okay, let's go ahead and say print page faults. We can call this page fault. Yeah, that's right there. And then for I in this tracker, I'll just go ahead and print I. Okay, so this is done. What I will do is if name equal to main. Okay, what I will do is I will just go ahead and initialize these two things that we talked about. So just do this, I'll edit this, do a tab over there, maybe do an underscore also over here, and similarly I just go ahead and set this to a variable. Okay, from here I'm just going to call the FIFO and pass this processes comma this frame size. Once I'm able to do this, let me just go ahead and run this. Okay, not this. Let me press the play button. Then you can see that the total number of page faults is 7. Wait a second, that's the same thing. Wow, let's go ahead and see what else is that. So initially 0 minus minus 0 minus minus 0 3 minus 0 3 minus 0 3 1 0 3 1 2 3 1 2 3 1 2 4 1 2 4 1 again 2 4 1 2 4 1, and the third time you also have a 2 4 1 2 4 1. Then it changes to 2 4 3 2 4 3, then it changes to 0 4 3 0 4 3, and then finally again 0 4 3. So this is how FIFO page replacement works. Now I'll give you a pro tip. Okay, rather than you hard coding this, if you're going for your lab exam, there's some very nice things that you can do. Rather than you hard coding, you can actually tell the faculty, maybe we'll set this to 3, but you can just randomize this. So what I want you to do is just import random. Okay, so import random, and instead of us defining all of this, we will just randomize this processes list. Okay, I'll just do something like random.choice of let's say pick something between 1 2 3 4 and 5 for in range of 10. So pick some random 10 processes, okay, and then do this algorithm. So when you do like that, it'll still calculate the same thing. You can, in fact, you can just go ahead and print the reference also. So print processes. So you can see what that looks like. You can see this is what I'm attempting to do, and then this is what FIFO looks like for that. Doing this, you can randomize and you can show that your algorithm actually works and does not only work for your hard-coded scenario. Okay, so this is FIFO page replacement. I hope you're able to understand what we're talking about here. If you did, fantastic. If this video helped you, hit that like button. If you guys have any questions, let me know down in the comments. I'll try my best to answer them. Thank you so much for watching. I'll see you in another video. Until then, bye.